Okay, so good morning. Today we will be discussing the first exercise of triangles. Lines and angles we have already discussed in three parts. Part 1 we discussed different types of angles. Part 2 we discussed about parallel lines and associated angles. Part 3 we discussed about angle sum property of a triangle. Now in this triangle chapter, what we are going to discuss, especially I am going to discuss about congruence of triangles. So let us see the different rule of congruence of triangles, and then we will solve exercise 7.1 also, which is there in CBSE book, and then we will understand that how we can go for congruence or congruent triangles, what actually it is. All those things we will have a discussion. Okay. Let us have an introduction first, that what actually is called congruence. So suppose if two triangles are given to us, one is A, B, C, another triangle is given to us as D, E, F. It is having angle A, angle B, angle C, having angle E, angle D and angle F. So you can say that each and every triangle consists of 6 parts, 3 arms and 3 angles. Means 3 sides and 3 angles. Each and every triangle consists of these many parts. So in a triangle. And triangle we will be denoting by using this symbol. Okay. So what actually is called congruent? So we can say that two triangles can be said as congruent if their corresponding sides and angles are equal. Mind it, we are not discussing about similar triangles. We are not discussing about similar triangles. That we'll be discussing later on in next video or in some another video. Here we are talking about congruence of triangles. In that congruence of triangles, compulsorily the corresponding sides and angles are equal. If AB is equal to DE, AC is equal to DF and BC is equal to EF, so we can say the corresponding side of BC is EF only. For AC, corresponding side is DF only. For AB, corresponding side is DE only. We cannot call the corresponding side of AB as DF or EF. So that particular part we need to remember. Similarly, if we say that angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F, it doesn't mean that angle A will be equal to some angle E or angle B will be equal to some angle F. No. Corresponding sides and angles are equal, then only we can say that two triangles can be congruent. Right? So if we are writing triangle ABC, if these conditions are getting satisfied, then triangle ABC, we are using this particular sign to denote that it is congruent, this particular sign. Okay. And triangle, we must write DEF. Sorry. DEF. We cannot write triangle ABC is congruent to triangle EDF. No, it is not. Similarly, triangle ABC is congruent to F triangle FDE. No, like this also we cannot write. We must write in this fashion. So these two are wrong. I hope everybody has understood that how they will be writing also, naming the triangle also. Now we will study different criteria which are also called as rules of congruence. Rules of congruence. The very first one is Sas criteria. So S means side, angle, side. This rule. So S, A and S. So SAS rule. Now if two triangles, again A, B, C, D, E, F are two triangles, and in this, if an angle, suppose B I will remove, if an angle is equal to angle E, corresponding angle. Similarly, if the side BC is equal to EF and again angle C is equal to angle F, so what we have seen that, sorry, it is not, it is ASA rule actually, sorry, we are talking about SAS. So one side, suppose AB is equal to DE and angle B is equal to angle E and BC is equal to EF. So two sides and the included angle are equal. If two sides and the included angle are equal, then in the two triangles, okay, in the two triangles, then the triangles can be said as congruent. Congruent. So you can say that a triangle ABC is congruent to triangle DEF. Right. So this is SAS criteria. Another one is ASA criteria. So I will not be writing more now here because already you are knowing how to write. So if it is DEF, two triangles are given to us. It is ABC. So here we do have angle, side, angle. That is A, that is S, that is A. It means, suppose in triangle ABC and in triangle DEF, we do have such condition as angle B is equal to angle E, then BC is equal to EF, and then further angle C is equal to angle F. It means the two triangle ABC will be congruent. So here you can see that it is angle, one angle, then here it is side, and there again angle. So ASA criteria. So with ASA rule, the two triangle will become congruent. So it is angle, side, angle. Right. Next one is Aas criteria. In this, any two pair of angles, any two pair of angles are equal and any one side, if in the two triangles any two pair of angles are equal and any one side and any one pair of sides are equal, then the triangles can be said as congruent. Means triangle ABC will become congruent to triangle DEF. If any two pair of angles are equal, it may not be fulfilling the criteria of angle, side, angle like this. It may not be fulfilling the criteria. Any two pair of angles. Okay, if any two pair of angles are equal, certainly the other third angle also will be equal. Okay, we do know angle sum property. So in this, any two angles, suppose angle A is equal to angle D and angle C is equal to angle F, and any one side AC, any one side AC is equal to DF. In that case, what we will be finding? We will find that the triangle will become congruent. And the rule will be said as Aas criteria. Aas. We will go to another criteria, that is SSS. In this, corresponding sides are equal this is equal to this one, this will be equal to this one. So here no angle is being given to us. We are not given any angle. The sides are given as equal. We know that if the sides are equal, it will become equilateral triangle. Equilateral triangle, sorry, no equilateral triangle. Why? Because equilateral triangle will be there in which all the sides in the same triangle when it is equal. Okay, when AB is equal to BC is equal to CA, then only it can be called as an equilateral triangle. Triangle ABC can be called as an equilateral triangle. So, we will not discuss about equilateral triangle. But yes, when all the sides are equal, then compulsorily all the corresponding angles also will be equal. All the corresponding angles also will be equal. Then it will be certainly fulfilling the criteria of ASA or AAS or SAS. So it will be fulfilling the criteria. So that's why when we do have all the sides, corresponding sides equal, then we will be having the two triangles ABC congruent to triangle DEF, and the rule will be SSS rule. Next one is RHS. This is applicable especially, this congruence rule is applicable to two right triangles, especially two right triangles. So RHS means, right, means the angle or the triangle must be a right angle triangle. Then hypotenuse, the corresponding hypotenuse should be equal and one corresponding side must be equal. So that's why it is called RHS rule. It means two triangles can be said as congruent, okay, if they are right angled, means we can say angle ABC is equal to angle DEF is equal to 90 degree, means right angle triangle. Now hypotenuse means AD is equal to, sorry, not AD, AC. AC is equal to DF. So hypotenuse, and any one side, either it may be AB or BC. So AB is equal to EF, one side. Then the triangle given will become congruent to triangle DEF using RHS rule. So total 5 rules of congruence we studied, and now we will see how we are going to utilize all those 5 rules. Especially for RHS and SSS, we will be utilizing another exercise is there completely, that we will use it. So question number 1 in exercise 7.1 we are going to use, and immediately quick review I will tell you that what we have studied, that is rules of congruence. Which are the rules we have used? We have used SAS rule, we have used ASA rule, we have used AAS rule, we studied, okay. Then we studied SSS rule, we studied RHS rule. These are the 5 rules we are going to utilize. Generally these two, SSS and RHS, we do have separate chapter where we will be utilizing it. Okay, but there is no criteria like AAA. There is no criteria of congruence, rule of congruence, where AAA criteria is there. No. So it is not there. So please keep it in mind that this is not there. ASA is there, AAS is there, SAS is there, but there is no AAA. Triple S is also there. Okay, so let us solve. In quadrilateral ACBD, okay, we are given two quadrilaterals. AC is equal to AD, right? And AB means AB bisects angle A, means this angle is also equal to this angle. Okay, so that triangle ABC is congruent to triangle ABD. Means we need to prove this triangle, okay, this first triangle is congruent to second triangle. So we will see in triangle ABC and triangle ABD. Now we will see that CA is equal to AD, or we can write AC is equal to AD, what it is given in question. AC is equal to AD, so it is given to us. Similarly, angle CAB is equal to angle DAB, so it is also given, or AB is bisector angle A. So one side we have proved equal corresponding side, one corresponding angle, and further AB you can say is equal to AB. So it is common to both. So we can say that side, angle, side. So the included angle is angle A, DAB or CAB. So it means triangle ABC will become congruent to triangle ABD using SAS rule. This only we need to prove. What can you say about BC and BD? Now, if these two triangles are congruent, it means BC will become equal to BD. What we are saying, it is CPCT. So, CPCT means corresponding parts of congruent triangles. Corresponding parts of congruent triangles. So always we will be using the word or the abbreviation CPCT. Okay. In next question, ABCD is a quadrilateral again, in which we are given AD is equal to BC. Okay, AD is equal to BC, it is shown. And angle DAB, where is angle DAB? DAB is equal to angle CBA, right? Prove that triangle ABD is congruent to triangle BAC. Okay, let us take it first. So in triangle ABD, ABD and triangle BAC. Okay. So triangle ABD and yes, triangle BAC. So we are having first of all, this side we do have, okay, ABD. So in ABD we do have AD, and in BAC we are having AD is equal to BC. Okay, right. Okay, and again included angle BAD, okay, or we can write angle DAB, no problem. Angle DAB is equal to angle CBA, okay, in triangle BAC, right, or in triangle ABC we can write anything we can write. So angle CBA both are equal, so it is given to us. It is also given to us. And in both triangle we find that AB is equal to AB, common. So we are having side, angle, side. So triangle ABD is congruent to triangle BAC using SAS rule of congruence. Okay. Then it means BD is equal to AC, correct? BD is equal to AC, CPCT. And angle ABD, okay, is equal to angle BAC. It will also become CPCT only. So angle ABD is equal to angle BAC, that is CPCT only. Right. Now in question number 3, we are given AD and BC are equal perpendiculars. Which one? AD and BC. So this one are equal perpendiculars on AB, so that CD bisects AB. It means we need to prove that O is the midpoint, okay, of AB. O is the midpoint of AB. This we need to prove. Whether it is the midpoint of CD or not, but actually we need to prove that O is the midpoint of AB. Okay, right. So it means if we will be proving this triangle as congruent to this triangle, it means the sides will become equal. AO will become OB. It means O will be the midpoint. Then CD will become to, sorry, OD will become to OC. Again, O will become the midpoint. We are given here, this is as 90 degree. And here also we are given 90 degree. We are not going to use here RHS rule now. Okay. So let us see how we will be able to solve this question. Okay. Now we can see that this angle is equal to this angle. Means angle COB is equal to angle DOA. Why it is? It is vertically opposite angles. Okay, so in triangle OBC and triangle ODA, we do have angle COB is equal to angle DOA, vertically opposite angle. We are having angle CBO is equal to angle OAD, that is each 90 degree. Okay. And one side we do have BC is equal to AD, which is given to us, which is already given. Okay. So it is given. So we found that two pairs of angles and one pair of side is equal in both triangles. Therefore, triangle OBC will become congruent to triangle ODA. Which rule? AAS rule. AAS rule. Therefore, AO is equal to OB, CPCT. Even OD is equal to OC, that is CPCT. Therefore, CD bisects AB, as O is midpoint. O is midpoint of AB. Right. Here L and M, these two lines are given to us. Two lines are given to us. L and M are two parallel lines intersected by another pair of parallel lines P and Q. So P and Q are also parallel. L and M are also parallel. Right. So that triangle ABC is congruent to triangle CDA. Okay, let us see in triangle ABC and congruent, sorry, not congruent, and triangle CDA. So ABC is this one, this triangle, and CDA is this triangle, right? This is the second triangle. So parallel lines are there. It means we need to use some associated angles. We can use alternate interior angle. We can use corresponding angles. We can use interior angles on the same side of the transversal or supplementary. Those type of things we can use it. Okay, let us see. So we see that once P is parallel to Q, means P is parallel to Q, and AC works like a transversal. Therefore, angle BAC means this angle, yes, means this angle will be equal to this angle. This angle will be equal to this angle. Alternate interior angle. Yes. And the side AC is common. So it will form ASA rule. Okay, so angle BAC is equal to angle DCA. Again, alternate interior angles. Similarly, AC is equal to AC common. Then angle BAC, we have already used it. So now angle BCA is equal to angle DAC, right? Again, alternate interior angles. With P is parallel to Q. Therefore, triangle ABC is congruent to triangle CDA. Which rule? ASA, rule of congruence. Okay, so the triangles have been proved as congruent. Now question number 5. Line L is the bisector of angle A. It means this angle is equal to this angle. Okay, it means we are given angle OAB is equal to angle BAP. Now BP and BQ are perpendiculars from B to the arms of angle A, means angle AQB is equal to angle APB is equal to 90 degree. These two things are given to us. We need to prove in triangle APB congruent to triangle AQB. Okay, let us see what we can do. So we can make AB as common, right? And two pairs of angles are also equal. Then we can use angle OAB is equal to angle BAP. So given angle AQB is equal to angle APB. Okay, first we will be writing for triangle APB. Okay, so in reverse we need to write. If we are writing this congruent, so first we need to write about APB. Okay, triangle APB. So triangle APB, if we are writing, then we can write angle BAP is equal to angle OAB. Okay, then angle APB is equal to angle AQB is equal to 90 degree. Right. Then we will be writing AB is equal to AP, so which is common side. Therefore, triangle APB is congruent to triangle AQB. Okay. So once they are congruent, it means BP will become BQ. That is CPCT. Means B is equidistant from the arms of angle A. Now question number 6. We are given already AC is equal to AE. Okay. We are already given AB is equal to AD. Right. We are already given angle BAD is equal to angle EAC. Means this angle is equal to this angle. Okay. So that BC is equal to DE. So BC is equal to DE. It means we need to go for congruency of triangles. So congruency of triangles will take in triangle ABC and triangle ADE. ADE. So in triangle ABC, we do have BA or AB. AB is equal to AD given, right? Then angle BAD is equal to angle, no, we are using angle ABC and ADE. So this part has become common. Okay, suppose X. Okay, so this part will become common. So that common part will get added for both. So it means we can write not BAD, we can write angle BAC. Okay, BAC is equal to angle, we can write DAE. Yes, we can write. So angles are equal, including angle DAC, including are equal by adding common angle DAC. Common angle DAC. Okay. Right. Further, AC is equal to AE. This is also given. We have got SAS. So triangle ABC has become congruent to triangle ADE. Which rule? SAS rule of congruence. Therefore, BC is equal to DE, CPCT, corresponding parts of congruent triangles. Okay. Now in question number 7. AB is a line segment. P is its midpoint D. Okay. Is its midpoint. D and E are points on the same side of AB such that angle BAD is equal to angle ABE. So angle BAD is this one and angle ABE this one, and EPA is equal to angle DPB, right? we need to prove this congruent. So triangle DAP and triangle EBP. Okay, so angle DAP and angle EBP. So we will go for P is the midpoint. Okay, so it will become ASA. ASA. So angle DAP is equal to angle DAP is equal to angle EBP. Right. Similar, here we can see that it is common angle, suppose it is X. So adding of these two will always be equal, because this is equal, this angle is equal to this angle. When we will add X common, so the angle PEB or the angle EPB is equal to angle DPA. Okay, then another one, AP is equal to PB, given P is the midpoint. Okay, P is midpoint of AB. So AP is equal to PB and angle APD is equal to angle EPB. Okay, so equal angles including X by adding X. Equal angles by adding X in both angles. Now SAS. So triangle DAP is congruent to triangle EBP by SAS rule. No, sorry, not SAS rule, ASA rule. ASA rule. Therefore, AD is equal to BE, that is CP CT. Okay. Now we are going to have this last question of this exercise. Given right triangle ABC. So right triangle ABC we are given, right angled at C. It means here it is right angled. M is the midpoint of hypotenuse AB. Okay. So it means this is equal to this one. We are given AM is equal to MB. We are given angle ACB is equal to 90 degree. C is joined to M and produced to a point D such that DM is equal to CM. So it is also given DM is equal to CM. It means this also will be equal to this, right? And point D is joined to point B, joined, okay, so that triangle AMC is congruent to triangle BMD. Okay, so let us see in triangle AMC and triangle BMD, which are the things are there. So AMC and BMD. So in that we do have BM is equal to AM given. Then angle BMD is equal to angle AMC. Okay. We need to write first of AM. Okay, AMC. I am writing in reverse, so it should not be there. First we need to write about this and then we will be writing about this triangle. So we can say that AM is equal to BM. Okay, then angle AMC is equal to angle BMD. So that is vertically opposite angles are equal. Okay, then CM is equal to DM. So now triangle AMC is congruent to triangle BMD using SAS rule. SAS rule. Okay. Now we need to prove angle DBC is a right angle. So once these two triangles have become congruent, 1 and 2, so it means DB is equal to AC. It means DB is equal to AC. Or first I will be writing from that side. So AC is equal to BD, CPCT. So we have proved AC is equal to BD. Right. So if AC is equal to BD and we can say that angle CAM also, angle CAM, I will be writing this side. Angle CAM is also equal to angle MBD or DBM. Yes. So what it is? It is alternate interior angles. Due to CPCT in both triangle, we can say angle CAM is equal to angle DBM, which forms alternate interior angle. Therefore, we can say that BD is parallel, or you can say AC is parallel to BD. AC is parallel to BD. That also we can prove. So once AC has become parallel to BD, right, then here I will be writing at the top. Okay, if AC is parallel to BD and BC is a transversal, then angle DBC plus angle ACB is equal to 180 degree. Why? Interior angles on the same side of the transversal are supplementary. So angle DBC we are not knowing, but angle ACB we are already given, it is 90 degree. So we have got angle DBC is equal to 90 degree. It means this angle also has become 90 degree. So this one we have proved, this one we have proved. This is also 90 degree. Okay. Now in triangle DBC, we will go for DBC and triangle ACB. So here what we have seen that this angle is equal to this angle, right? Similarly, this angle is equal to this angle, though it is 90 degree only. Okay, this is also 90 degree completely. Let us see now another point here. Okay, so now I need some space to find out that whether DBC we can prove. Yes, we can prove. So DBC and ACB, very easily we can prove it. Okay, so here we will write in triangle DBC and a triangle ACB, we will be able to prove very easily. Why? Because DB is equal to AC. proved already. Similarly, angle DBC is equal to angle ACB is equal to 90 degree each, and BC is equal to BC common. Therefore, triangle DBC is congruent to triangle ACB. Which rule? SAS rule. Okay, right. So it means DBC and ABC or ACB. It means what? It means AB is equal to, or you can say DC is equal to AB. DC is equal to AB, and DC is equal to what? 2 cm. Can be written as, so here I will not write. Now we have got here DC is equal to AB. DC is what? 2 times of cm we can write AB. So cm will be half of AB. So this also we have proved. No, this one 4. This also we have proved, and this also we have proved. So in this way, we have seen that how we are utilizing the different rule of congruence to solve the problem. We have not used till now SSS rule, that is side 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 rule, and RHS rule. We do have a separate exercise in our CBSE book where we will be using this RHS and SSS. So in many of the questions we can use RHS also and SSS also, but we have not used it. We have used SAS, we have used ASA, we have used AAS rule. So these 3 rules only we have used it now. So thank you very much. I will be coming back very soon with next video and with next exercise also. Okay, so thank you very much.